Hi, so today I'm going to be going over an 820-2530 motherboard that is dead. This video is probably going to be out of sync. I have a lot of other encodes going in the background. I just lower the priority of them, and I also lower the affinity, so I say only work on this CPU core, and I have file transfers going. I always try to record to a different SSD than the one I'm transferring files to and from. But yeah, the reality is, to actually put out the amount of videos that I do in this quality on one computer, it's pretty difficult. I'm thinking, I could just solve this problem by just moving everything over to an encoding computer that's just constantly getting skull-fucked encoding videos, but that requires buying another computer, and I'm cheap. So I'm going to stop this video and see if it's actually in sync, and if it is, then I will start and continue with how we troubleshoot this board. Alright, so I think this did it. So what I did is I make Open Broadcaster high priority. I make sure that the drive that I am recording to is not a drive I'm doing transfers to and from. I have 4 SSDs plugged into this computer just filled with 1 terabyte, 1 terabytes of random clips of like this border pair, that border pair that are all unlabeled that I have to go through later. And I also have a RAID 0 array that I use for capturing. I figure that 2 SSDs in RAID 0 will be enough for a 1 video capture and also occasionally transferring stuff, but it's not. So I have so many SSDs in this computer, I've lost count. So I'm recording to an SSD that is not an SSD that I'm transferring to or from, and I'm making sure that all my encodes or renders are set to the affinity, the same core CPU affinity, but instead of it using all processors, it's only going to use 1 of the 6 cores. That being said, hopefully this ends this bullshit where none of my videos are in sync. Yeah, it's something I could totally solve by buying another machine, which, again, I didn't even want to build this one. But yeah, so let's get on with it. Hopefully the audio is fixed. So we have a green light in the charger. The green light in the charger tells me that I'm burning my finger here. Great. Oh, the board is telling me what's going on with it already. Hello. Anyway, so we have a green light in the charger. It means PP3V42 is present. If you watch my one-wire circuit videos, you'll know why that is. We need 3.42 volts for the one-wire circuit to function and for the green light to turn on. So now we're going to go over to the board schematic, and let's go over to the schematic and go through the different power rails. On page 7, you're going to find all the different power rails in the system. I'm surprised they didn't just etch this into stone. Did they even have PDFs in 2009? Did they have, like, pen and paper and ink? I'm pretty sure, because if I had to guess, I would have guessed that they just had, I would have guessed that they just had stones and rocks and chisels. So in this old piece of shit schematic, what they do is they put the most important stuff last and the least important stuff first. So what the average person is going to do here, the mistake that the average person makes, is they look at this list of rails and they start with the first one, right? No, you don't. Because what it's listing first is SO rails. So let's just go over what the power states mean for a minute. So we have S5, means, the rails that I would expect to be present when the computer is off. I'm just sitting there with the battery plugged in. We have S3, rails I would expect to be present once the laptop is in a sleep state. So let's say, you close the lid and you see the little blinking white light in the front that says that the MacBook is sleeping. You have G3 hot rails, which, to be honest with you, I never bothered to do the research to figure out the difference between S5 and G3 hot. G3 hot means always present. S5 is present when it's off. So to me, that's the exact same shit. And over here, we have SO rails. The SO rails are designed to be on whenever the computer is, on. So it's on and working. So if the computer's not turning on, why would we check the SO rails first, particularly if those rails are only supposed to be present when the computer's on? Makes no damn sense. So we're going to start with the G3 hot rail over here. Now, as I said, PP3V42_G3 hot is already present. I know it's present because I have my light. And as I say, if we scroll over to the logic gate setup for U6901, over here, PP3V42 powers this logic gate, which will then power this IC, which allows the external, which is the charger's adapter sense line, to talk to the internal, which is the SMC. So we wouldn't have any of that without PP3V42. So seeing that light means that it's present. Now, if we go back to page 7, the next rail that's supposed to be always on is going to be PP18V5 DC-in connector. Now, let's think about this for a second. If the DC-in board, the DC-in connector, if the charger wasn't providing power to this board, would I have PP3V42? No, common sense, so I can skip over that one in troubleshooting. Going down to the next one on the list is PP Bush G3 Hot. This is a rail that's supposed to be always present, so if I search for this, and I'm going to go over to this board view software. A lot of people wonder how I find this stuff on the board. I'm just going to hit N, and it's going to show me every point that it shows up. There's a nice big fuse over there that I can check, so we're just going to... And you can see the fuse under the microscope right here. So, do this. And I'm in resistance mode. Great. See, the good thing about having this meter is if I had the $10 meter, it would have smoked by now. 12.53, good enough. Next rail on the list is going to be the S5 rails, right? So let's check PP3V3 S5. So I see that over here. S5 rails. S5 is going to be the stuff that's supposed to be on while the machine is off. So PP3V3 S5. So we're going to find where that is on this clusterfuck of 1995 software. And okay, I can find it on this little point thingy over here. So let's try to find that point thingy on... There. Customer walked in. All right, so let's try and find that now. So we're looking for this probe point. That's what's... And as always, the software always loads the board view in the opposite position that I have this on the desk. Go fucking figure. And look at how many... What the fuck is this? Look at how many probe points there are on this board. Look at this. Look at this shit. Look. Okay, well, no, seriously. Now, so I'm looking for this one over here, right? This thing. Yeah. You know, doing window capture sucks because I have the mouse in a different spot than where you see the mouse. So let me just change that because that entire thing sucks. We're going to add screen capture. Even though it's 1 frame a second, it's better than this BS. Screen capture beats window capture by far. So we're going to do display capture, add my existing one, and add you in. Above, and bam. All right, as much as, you know, it's not the best, but at the very least, it makes a little bit here. There we go. So even though the mouse is moving slow. So you see that probe point up there? Look, which one is that? Is it this, this? I'm just going to take a wild guess that it's this. So let's see what I get. On the multimeter, actually I can't see it because I'm in the wrong view now. On the multimeter, I get 3.3. All right. Now let's check the rest of the stuff in this area. What would I expect to see? Another rail that I would be expecting to see. Let's move up. PP5VS3, right? PP5VS3. Let's look for you. The Skype message is from a dude that didn't pay his bill 2 months later. One thing you should do is never, ever, ever let somebody give you a check. Like, I had a bad feeling about accepting a check from this dude, and he just kept begging me for a part last minute. I just kept saying, just buy it somewhere else, just buy it somewhere else, just buy it somewhere else. And he decides that he's going to, you know, just keep asking me, and I finally just feel bad, and I give him the stuff. And he gives me a fucking check. And, like, I haven't taken checks ever, and, like, the one time I decide to take a check, it bounces. Checks are bullshit. I mean, really, think about this. Let's see, what voltage are we getting here? Are we close to our problem? A check is pretty much saying, I don't have any money, right? I have no money on me, I have no money anywhere, but I have this little piece of paper, and I'm going to write on it that I have money. And if you call these people, like Seinfeld actually had a good skit about this. Yeah, it's definitely from one of the first episodes of Seinfeld. It's like, if you call these people, they'll tell you that I have money, I promise, I swear. It's like a fucking absence note. Like, taking checks in 2016 for services or parts you already provided is just such bullshit.
Louis, can I pay for this repair with a check?
Fuck you. That's Pete. So we have 3.3 volts there, but we don't, and we have, let's see, we actually have 5 volts here for PP5VS3. Do we? We do. Yeah, I may actually wind up publishing that person's information if they don't wind up paying me, but we'll see. I'll give them a chance. But never give shit away if they haven't paid for it. It's the absolute worst. Oh, fuck. You keep Skyping saying, sorry, I've been busy, blah, blah, blah. No, fuck you. Fuck you, pay me. All right. So now we move on to the next rail, because that rail is present. PP3V3S3. Let's see if this one's present. I also actually didn't check PP1V05. Let's check that one. That's a very common one in the machines with C7771 present, where they use the tantalum capacitor instead of an electrolytic or a polymer film. Oh my god, what a fuck up. What a fuck up. Okay, they're going to call it something different than I'm used to it being called. So I'm just going to find the component that's on and go from there. Oh, duh. All right, so yeah, I'll just measure it on C7771. As you can see here, they were smart, and they didn't use a tantalum. See, that little tantalum piece of shit is responsible for so many dead 15-inch 2008, 2009 machines. And then the kernel panicking in 2010. All right, so the reason I had to skip ahead is I got a call from some dickhead telemarketer. So let's see, do I get 1.05 volts here? Is that the right? Let's find the component. So I'm looking for this thing, C7771, right? This thing over here. And it just changed the orientation on me. Thank you, shit board view software. All right, so let's find this. It's going to be a cap looking up by here. Interesting. So PP1V05 is missing. Am I on the right place here? Let's see. Am I measuring right? How the hell can I have PP5ES3 without having this one? Let me just measure on the coil. Let me make sure I'm not losing it. I'm going to measure on L7770. Let's check L7770. We're going to check right here, right by the MCP itself. I have to hit F4 so that I can see my own multimeter on the screen. Nothing. Okay, I think we're getting somewhere. But this really begs the question, though, of how is it that PP5VS3 can be present if the MCP isn't turning on? Because the MCP is what's going to send the PM sleep S4L signal, which is going to tell PP5VS3 to turn on. And if I go here, I believe PP5VS3 is started. Okay, it's not exactly all the way there, but, you know, something. Interesting. All right, so let's see how PP whatever here is created. So this is created by... What was I just talking? Here we go. This is created by... So this is going to take 3.3 volts and turn it into 1.05. So let's see if PP3V3S5 decided to magically disappear. So we're going to check on U7750. I'm going to check to see that the enable is there, and I'm also going to check to see that it's receiving input on the VN pin. Because remember, even if it's getting input on the VN pin, it's not being told to turn on, nothing's going to happen. So let's look up U7750 here. U7750. Okay, U7750 is right here. All right, so I'm interested in voltage on pin 1, and I'm going to be interested in voltage on the enable pin, which is, I don't even remember. Is it 1, 2? Here we go. Okay, pin 2. Why the fuck did I call it something different? PMG2, you know, fuck you. Call it what you call it on the schematic. I don't get this. Why do you write this on the schematic and then this on the fucking board view? This makes no sense. It's this stupid shit does not confuse you. All right, so let's see if we have voltage going in and enable going in. Remember, we need both, not just one. So let's check it out and see what we get.
feed the meter.
All right.
You think they take a check at the meter?
I think they take checks at the meter. They even take post-dated checks at the meter. Yeah, don't take checks in business. Okay, so we're supposed to have 3.3 volts going into this IC. And we have 1.9. So even though I measured PP3V3S5, here's the thing. I measured PP3V3S5 just a fucking minute ago, and it measured what it was supposed to. Now it doesn't. All right, now we're getting closer here. Now let's measure around the IC responsible for PP3V3S5. This is the stuff that's going to get new people. You measured it a minute ago and it worked, and now you measured it and it didn't. So let's check this out. Let's go around the PP3V3S5 area. That's going to be the U7200 IC. This is the stuff where I legitimately feel bad for new people getting into board repair, because this type of stuff is just fundamentally demoralizing when you get trolled this badly. So this created by U7200. So let's take a look at what's going to enable some of these S5 rails, right? So we have ENO, N-trip, and N-trip. Now the way this works with the N-trip pins is... Oh, dear God, this is an awful fucking schematic. Okay, so can anybody tell me where this goes? Can anybody tell me where this line over here goes? This line from Q7221. Where does this go? Where the fuck? This goes here, right? But how the fuck would you ever know that from this bullshit schematic? Like this board schematic is so fucking awful. I mean, you know why they say over here, do not reproduce or copy or publish it? It has nothing to do with proprietary property. It has to do with the fact that they are fucking embarrassed that somebody may see just how bad they are at the internal documentation. Is it any wonder that Apple products have a new extended warranty or recall every single year when they can't even draw how the shit is put together properly for their own internal fucking documentation? Look at this. Look at this shit. Like, what the fuck is this? Well, like I got high that day, so I just decided to put, end the line over here by this little box instead of having it go up here. And what the fuck is this? Well, what's this bullshit? Look at this. Look, what is this shit? Look, watch. This line could go to the resistor and go down, but what the fuck is the point of drawing a box? It's like, hey man, I'm gonna draw a line. And they just fucking pass out drunk. Like, I don't get it. If you're going to do this stuff, do it properly. Anyway, the way this stuff works is usually the chip is going to naturally be on. So you have chips that are not always on, and then you have chips that are always on that have to be turned off. So for example, ENO, this means that I have to send voltage to here to turn this function on. N-trip means that it's naturally on, but I have to trip it to turn it off. A little confusing. So if I wanted, let's go over to a backlight IC. Let's go over to something simple. Okay, so this chip has an enable line. Now the thing with the enable line, very simple, is this chip is naturally off, but if I send 3 volts to the enable pin, I turn it on. That's enable. I send voltage to it to enable it. Now when it comes to these N-trip pins, the way these work is they're always naturally on. It has 3 volts being created internally to turn this on. Now, it's not that I am going to turn it on by sending voltage to it. It already has voltage there. What I have to do is I have to take away that chip's voltage that's already there in order to turn it off. And the way we do that is with this transistor that's going to ground, right? So there's a transistor here that goes to ground. It's going to take that N-trip voltage and say, fuck you, send it to ground. I hope. My brain has not exactly been what it used to be lately. And this line is supposed to be going to here because that's where this goes to. It doesn't. The electricity just doesn't go in a little fucking box and go around in circles like some stoner from the 60s. It's supposed to actually go somewhere. But apparently, again, this is Apple engineering. Think different. But you know what? Fuck it. Let's just not think at all. So, where was I with this? Yeah, so let's start checking the enable signals here. Let's check ENO. Now, ENO comes from this resistor, and this resistor attaches SMC PM G2EN to this signal. And we can tell that because they decided to actually draw a line and not some random bullshit throughout that part of the motherboard. So I'm going to plug it in. Let's just check what's going on with the enable signals here. So SMC PM G2EN, right? Let's check that on R7273. So we're going to go over to R7273. The way that Apple writes out schematics, fucking be ashamed of yourself, man. My handwriting in 2nd grade was better than that shit. Like, it may have been chicken scratch, but at least you could get... At least the point was there. For fuck's sake. Take some pride in your $400 billion engineering. $400 billion company can't draw a schematic. What a joke. Wow. And I remember, like, I've worked on audio gear where the schematics that you got were literally photocopies. I mean, like, some of this shit was from the 50s and 60s, so you had a photocop schematic of a hand drawing, and that shit was better than this. Anyway. All right, so we're looking over here. Oy vey. Okay, this is rotated differently than how I'm looking at it. Let's see. Yeah, let's rotate this properly. Okay, so SMCPM G2EN is going to be on the left side of this resistor. And I got 3 volts. Now, the side where it's going to the chip is 0 volts. Okay, so now we have 2 different things that could be wrong here. Either that resistor is blown and not allowing SMC PM G2EN to the U7200 buck converter controller, or the buck converter controller is pulling the signal down on the other side of that resistor. So if that resistor itself is higher than the 100 kiloohms that it's specified for in the schematic, that means that the resistor is blown. However, if that resistor is 100 kiloohms or lower, that means that the buck converter controller chip is what's pulling the SMC PM G2EN signal down. So let's measure resistance on that, and I'm pretty sure that the signal is being pulled down because that chip is intermittently fucking itself up. It's 49.4 kiloohms, which is below 100 kiloohms, which means that my U7200 is what's screwing all this up. So I'm going to turn on my Weller WHA900. I'm going to, take a break, take a piss, make myself some breakfast or lunch, come back in a half hour. Hopefully this thing will have actually heated up by then. You can tell I'm being a bit snarky because my JBC died. And now I have to go back to this, and I had no idea how much patience I lost in terms of waiting for shit to heat up. I have none. I have absolutely none. I said that this is a good device, and I stand by me saying that it's a good device at $600, but I'm spoiled. I like the $1,800 one. I hate this thing now. I really do. Like, this thing takes so long to come to temperature. I've almost forget, I forget what I was doing on the damn motherboard. So, this chip got to go. Okay, now remember, it's going to take a while here. This isn't something that's going to melt immediately. Or even in a, We're back to the old station. Until I can figure out if JBC is interested in fixing my JBC for money. I sent them an email just asking, like, what would it cost me to buy this thing? And it didn't fail because it's a bad station. It failed because I'm an idiot that shoved the spatula in there that I was trying to use to heat up a MacBook Air bezel, and I stuck it a little too high up in there. And as a result of that, I shorted the heating element to ground. Okay. Take the chip off the board. A lot of people get the orientation of this chip wrong, so what I do is I actually solder it onto my table. That's why my desk looks like shit. But I don't care if my desk looks like shit. My desk looks like shit, but my chips are always soldered on the right way because I solder the component to the desk. While it's still hot, I shove it onto the table. At the end of the day, I knock all that stuff off and I clean the desk, but... Alright. This iron would look so much better if I flipped it on. Heat. Are we hot yet? Are we hot yet? We're kind of hot. There we go. That beautiful sound, that means we're at solder melting temperature. A lot of people asked recently if I hate the sounds of the HAKKO so much, why don't I take off the speaker? I love that little noise when it goes beep. It's like beep. I'm ready. That's such a cute little noise. It's when it goes non-stop when it does that shit when I'm changing irons. That pisses me off. But if I remove the speaker, then I lose that adorable little beep, and I don't want to lose that little beep. And I'm sure that there's probably a method if I go through all the manual settings that I can maybe turn off that annoying noise when I'm changing irons. It's just, have you seen how shitty the interface to this thing is? I don't want to read a manual to figure that out. The interface to this thing is so garbage and bad that, nah. I'm not going through that alarm clock and guessing what everything means. Yeah, it may be in the manual, but it's not. If you have to read a manual to figure out how to make something stop beeping, then that's lame. There should be some general user intuitiveness to the process. At the very least, it just shouldn't be. Its default behavior should not be to be that annoying. But I love the adorable little beep that it gives me. Okay, and I can also see that whoever did this tried to hide the fact that they ripped the fan connector off of the board. So I'm guessing that this has been somewhere else before. You see that? Because that just came right off. And there are no pads. Lovely. So let's try and reconnect the fan connector. Be nice. And then I'm going to have to epoxy it down there because there's no pads for the anchor pins. Wow, this is one fucked looking connector. I should be using a smaller iron for this. That connector is screwed. Let's see if we've made any progress. So what I'm looking for is fan spin. I would be surprised if the fan ever spins on this thing, but with what that looks like, it could work and I probably wouldn't even get a fan spin. Let's see. Any progress? No dice. Alright, let's see. Is did PP3v3S5 go? Oh. The fan's not spinning because of this friggin' connector. I'm probably just going to have to replace it. Alright, let's see. Well, I didn't turn it on because the CPU is not getting warm. So let's go back and see if PP3v3S5 is present, shall we? Let's see. PP3v3S5. Gotten anything? PP3v3S5 is supposed to be present on the input of this IC. So it's there. Alright. Enable. There. PP1V05 is there. Okay, so we've made some progress here. This is stuff that I didn't have a minute ago. Which begs the question, is this thing just turning on and I don't see the fan spin? Because the fan connector is that fucked up. And seeing as I didn't burn my face when I touched the... I didn't burn my face when I touched my chin to the CPU, I'd say that it's not on. So let's see. Shove the fan in there. Try turning it on one more time from the tweezers. No dice. All right, so down the list, and let's continue troubleshooting here. Okay. Let's go down the list. What are the other rails? I guess I should double check and make sure that PP5VS3 is still there. Is not. PP3V3 is there. PP5VS3 is absent. Yeah, it's usually supposed to... Actually, this is one of those older ones. It's not going to show up until you hit the power button. So I have to hit the quote-unquote power button. Let me just put some better solder joints on the power button. These are used up. Okay, now plug it back in. Nice firm press there to turn it on. Boo. You see what dumbass did here? Check out what dumbass did. Sent Ntrip to feedback. That was stupid shit. I'm not editing that out. No need to edit that out. People should see that I'm an idiot. Alright, let's try this again. Plug in the MagSafe. I plug in a fan. And I hit power. Yeah, I'm a fucking idiot. I'm a fucking fucktard. Total fucking idiot. I bridged it. But yeah, that was it. So the U7200 was the issue. It was intermittently working. I was actually getting hot in the beginning, and I'm just remembering it now. I should have noticed that immediately, but I noticed it 40 minutes in because I have no brain anymore. And that's that. So, as always, I hope you learned something. With any luck, this is actually in sync, but we'll see. And, man, I don't know. I still feel better about myself than I do about that dude that can't draw a line that drew the schematic. But that's it for today.